This is the shorter version of practice problem number 4 from lesson 14, solving more systems, and unit 4, linear equations and linear systems. The longer version just has more detail. In problem number 4, there's a system of equations made up of two equations. This equation, x minus 6y equals 4, and the second equation, 3x minus 18y, also equals 4. And this system has no solutions. So when you see a system that has no solutions, that means that the graphs of these two equations, those lines are parallel lines. They have the same slope. They will never come together. They will never intersect, and they have different y-intercepts. So the slope is determined by the coefficients. That's the number that's right next to the variable. So in this case, it's 1, this is a -6, this is 3, and a -18. And the y-intercept is determined by this constant term, this 4. In this case, the 4 in this equation and the 4 in this equation. So A says change one constant or coefficient to make a new system with one solution. That means change one of these equations so it has a different slope. If it has a different slope, they will intersect, those two graphs will intersect somewhere. So change the slope. I'm going to change the slope by changing one of these four coefficients, either this 1, this -6, this 3, or this -18, and the graphs will intersect. And B says to change one constant or coefficient to make a new system with an infinite number of solutions. That means they are essentially the same equation. They are right on top of each other, so there's an infinite number of solutions. So they will have the same slope and the same y-intercept. And we're going to change either this 4 to make the constant different, to make the constant match this equation, or this 4 to make the constant match this equation. The standard form of equation is this form. It's ax plus by equals c. And you calculate the slope from this form by taking the opposite of the a coefficient, which is, again, the number that's right next to the letter, and dividing that by the b coefficient. So for one solution, you're going to change the slope. So you're going to change either a or b in either equation. We're going to change one of these four coefficients to change the slope. And for b, it says write a system of equations that has an infinite number of solutions. Well, they already have the same slope, so they are parallel, and now we're going to make them graph right on top of each other. So they're going to be the same solution, the same equation. You do that by changing either this constant, this 4, and the y-intercept calculated from this 4 to match this equation, or this 4 to match this equation. So for number 1, the slope is determined by this coefficient 1 divided by -6, and it's the opposite of that value. So it's the opposite of a -1/6, which is a +1/6. So this slope for this equation has a slope of 1/6. For equation 2, it is a, which is 3, divided by -18, and it's the opposite of that. So the opposite of a -3/18 is a +3/18, which simplifies to 1/6. So they both have the same slope, 1/6. Now notice that slope in each case is determined by this coefficient 1, -6, or 3, this 3 right here, and -18. So changing any one of those four, this 1, this -6, this 3, and this -18, will change the slope of that equation. Once you change the slope, and they have different slopes, they will intersect at one point. For B, it says change the constant. Well, the constant is the y-intercept, and that's calculated as c divided by b. So in this case, it's this 4 divided by -6, which simplifies to -2/3, or it's this 4 divided by -18, which simplifies to -2/9. So we're going to change this 4 so that this y-intercept matches this y-intercept, a negative 2/9, or we're going to change this 4 so this y-intercept matches this y-intercept, which is a negative 2/3. Either way. So here's a graph of these two equations. Equation number 1 is right here. Equation number 2, they are parallel lines with a slope of 1/6. The graph of equation 1 has a y-intercept of negative 2/3. So these are 3 grid lines this way. That's a negative 1. So this is negative 2/3. And equation 2, this graph has a y-intercept of negative 2/9. So this is a negative 2/9 right there. So for A, we're going to create a system of equations that has a single solution. So I'm going to choose to change this coefficient, this 1, to this 2 right here. Do that, it changes the slope. So this is now equation 3, and this is the graph of equation 3. So we're changing 1 right here to 3. We're changing this slope from 1/6 to this slope, which is now 1/3. It's this 2 divided by negative 6, and it's the opposite of that. So the opposite of a negative 2/6 is 2/6, which simplifies to 1/3. And so this system made up of 2, graph number 2 and graph number 3, now has a single solution at 8/3 and 2/9. Now I have a longer version of this problem that explains how you calculate that, and it goes into more detail about the standard form of the equations. Now the slopes are different, a single solution, a single intersection. For B, I'm going to change this 4 to 12, and that's going to cause this y-intercept to be 12 over negative 18, which simplifies to 2/3. So it's going to simplify to the same y-intercept in negative 2/3, and it's as if we're taking equation 2, or the graph for equation 2, and sliding it down so it matches the graph for equation 1. So 2 is going to slide down and become 4. So change this 4 to 12. That changes the y-intercept to negative 12/18, which simplifies to negative 2/3. Now you can confirm that by observing that this equation now is just a multiple of equation 1. If you multiply each term by 3, this is 3x plus a negative 18y equals 12. So these two equations match. There are equivalent equations, just written in different forms. 4 is a multiple of 1. So 4 is the same equation as 1. It's just each term is just multiplied by 3. So in the end, what I did is I changed, for A, I changed this coefficient 1 to this coefficient 2. And for B, I changed this constant 4 to this constant 12. So this changes the slope, so they have a single solution. This changes the y-intercept. Doesn't change the slope, but it changes the y-intercept, so the graphs are right on top of each other, so they have an infinite number of solutions.